This is looking at the ellipse and parabola and creating identical portions of an ellipse or parabola that were given in the question. So just having a look at an example question. This is from 2018. The first part of it there, the curve ABCD is a portion of an ellipse with major axis AD. And then the second part of this is highlighted in yellow. The curve UV with vertex at U is an identical portion of the same ellipse. So we're just going to look at how you would find that how you would find that curve, the top part of that UV. So I set up the question similar to what they asked for. The measurements are different, but the idea is the same. So I have my curve ABCD here. This is point U, so I need to create an ellipse that is identical to a portion of this. It's going to come down along this way here somewhere. Now U is being a vertex, so we can take that as either B or D, and we need our curve to come down along this way. So U, we're going to say that this curve here needs to be turned so that our curve is going to come down, so that would be the major axis there. So to do this, we need to find points along our curve down here. Yeah, you could, if you wanted to, come along, redraw your major axis, redraw your minor axis and draw the whole thing, but that's a bit slow. So a quicker way of doing this is to take coordinates. So taking points out along our lines of known distances. So I'm going to mark out here sections of 10 millimeter or 15 millimeters, 30, 45, giving me part of the curve along here. So let's call it 1, 2, 3. I'm going to find the same 3 points, measuring from point U. So we've got 1, 2, and 3. Now it goes into the curve, and that probably will be necessary. So what we're going to do now is we're going to measure the distance. So we've already come down a distance here of 15 millimeters. So now we're going to, for each point, measure the distance out to the curve from that point. So if I take this one here, that distance, I'm going to measure that distance, set it up on my compass. So I'm measuring that distance there. I'm going to mark that same distance out along the line up here. So up along here, copying that same distance out, highlighted in red. That is the same distance. If I do the same thing now from 2, so I'll do a different color. That's 2, so that's going to be the green distance, whatever that distance is. Copy that on my compass, mark it here. That is the distance for 3. The second point. For a third point, I'm going to do the same thing. So I need to measure the distance out that it is for 3. So I'm measuring the distance from the axis down to the curve, copying that same distance off out here on the side. Happens just to touch off it. Generally you will need to bring it inside, so the fourth point there is going to be 10 mil inside it. And my minor axis is 35. So bring your point, make sure your curve continues inside the other one. So drawing this slightly to start off with. This plots my curve. Then you can go back over and darken in the points that you have there. And there we have drawn a similar portion of an identical portion of the ellipse. Same thing works for the parabolas. So what we're doing is we're measuring a known distance down. So this is 15, 15, 15, and 10. So 15, 15, 2 to 3 is 15, and then we're left with 10 here. And then we're measuring the distance from our axis, the axis, out to the point on the side, out to the point on the side. From point 2, measuring the green distance down here, copying that distance up here. Same thing for point 3, point 3, point 4, and so on.